Hello. So for this question here, we are asked for a few things about this circuit. They want me to draw the power triangle for the circuit, and they want to know what's the power factor for this circuit, and they want to know how much power is dissipated by R4 and what kind of power is it. So R4 is right here, and since it's a resistor, it is going to dissipate true power, because remember, in our power triangle here it is. That is the angle of our power triangle. This is apparent power right here, the hypotenuse. The true power is right here. So that's the power that's dissipated by the resistive elements in the circuit. That's the bit of the power that's doing the work. And then we've got reactive power right here. So we're trying to get that power triangle for this circuit right here. There's a few ways that we can do this. I would like to find the apparent power for this circuit. And just to refresh here, I know that the apparent power can be found for this circuit in three ways. We've got the total voltage squared over ZT. We've got another way, which is total voltage times total current. And finally, we can say the total current squared times ZT. So any of those are going to give me the apparent power, which is the hypotenuse of this triangle right here. And coincidentally, the power triangle is going to have the same angle, theta, as the total angle of the impedance for this circuit. So that is how I'm going to know the angle of the apparent power. This is how I'm going to get the magnitude over here. So anyway, let's figure out what the total impedance is of this circuit. I've got a little bit of work that I've got to do here. I see that R3 and 4 are in parallel. So R3 in parallel with R4, let's see what that is. So that's going to be 10K times 4700 divided by 10K plus 4700, or 14,700. And that is giving us 3.19K. All right. So these two in parallel are 3.19K. What else do I see here? Well, I see that we've got XL here in parallel with R2. So let's do that. So we'll say XL in parallel with R2 is going to be, and let me do that. So XL has an angle of 90 degrees and R2 has an angle of 0 degrees here. So I'm going to do product over sum to find out what the equivalent impedance is there. So I'm going to need to include all these angles. So let me do it here. So we got 3K at an angle of 90 times 3.3K at an angle of 0. So there's my numerator, divided by 3K at an angle of 90 plus 3,300 at an angle of 0. And we get 2.21 kiloohms at an angle of 47.72 degrees. Okay, so let's redraw the circuit here, since I've now collapsed a couple of things. So our circuit is going to look like this. I'm going to draw this kind of small because there's a lot of computations that are going to happen on this page, and I don't want to run out of room. There's the source right there. So this and this collapsed into that, and then also touching that node right there is going to be this one. So this one is 3.19K at 0 degrees ohms. And this impedance right here is going to be 2.21K at an angle of 47.72 degrees. Okay, well, we've got to add these two together. So let me do that right now. So I've got this impedance on my calculator right now. So I'm going to say plus 1K at an angle of 0. And so our circuit then becomes 2.98K at an angle of 33.37 right there. And then we've got this. And finally, we've got this right here. And I'm just drawing resistors, even though these are complex impedances. So 3.19K at 0 right there. Well, you notice that that's in parallel with this. So this and this impedance are in parallel. So let's do it. Product over sum here. So 3190 at an angle of 0 times 2980 at an angle of 33.37. So there's my numerator, divided by parentheses, 2980 at an angle of 33.37 plus 3190 at an angle of 0. And I am getting this. Running out of room here too. 1.6K at an angle of 17.26 degrees. Right there. And that is all in series with the capacitor, which is 5K at negative 90. Okay. So these two are in series right here. So let's add them. So plus 5K at an angle of negative 90. And that gives us this right here. So this is 50 volts. And our total impedance, ZT, right here, is going to be 4.77K at an angle of minus 71.24 degrees. So that is ZT. Had to work pretty hard to get that. I know that we're asked about what the power is through this resistor. And so because of that, I'm just going to get IT here right now. So IT is going to be 50 volts at 0 degrees divided by zt, which is 4.77k at minus 71.24 degrees. So I know the angle is going to be 71.24 degrees, and that is amps. And let's see what the magnitude is. 50 divided by 4770 equals 10.48 milli. So 0.01048. So that is IT. Well, we can now find the total apparent power here. So that is just going to be IT times VS. So let's do that. So we've got IT right here. So I'm going to say IT times 50 volts at an angle of 0 degrees is, let's see here. I'm going to draw the power triangle now. So PA is going to be 524.1 millivolt amps right there. And the angle of this is going to be minus 71.24. So 71.24 degrees right there. Let's find the reactive power here. So it's going to be 0.5241 times the sine of this angle. So that's 71.24. And that has given me 0.496 var right there. So that's 496 millivar. And let's see what the true power is here. So the true power is going to be the apparent power times cosine of theta. So let me change the sine to a cosine here. That is giving me 168.55 milliwatts right there. Okay, so that is the power triangle for this circuit. What is the power factor for this circuit? Well, the power factor is just going to be cosine of the angle of the impedance, which is minus 71.24. So it's going to be cosine of 71.24 degrees. So the power factor is 0.32 for this, and that does not have units. It's just what the power factor is. Finally, we're asked how much power is dissipated by R4? What kind of power is it? Well, it's a resistor, so it's going to be true power. But let's see how much power is dissipated there. Well, in order for me to know that, I need to know what is the voltage right here. That's not going to be too tough for me because I know that the voltage right here is 50 volts. 50 volts minus the drop across the capacitor there is going to give me VA. So VA equals 50 volts at an angle of 0 minus XC times IT right there. So let's fill this in. VA equals 50 at 0 minus, what is that? 5K at negative 90 times 0.1048 at an angle of 71.24. And let's see what we get. So VS is 50 volts at an angle of 0 minus, and then parentheses here, 5K at an angle of negative 90 times IT, which is 0.01048. I forgot a 0 right there. times, or sorry, at an angle of 71.24 degrees. There. And it is telling me that VA is 16.85 volts at an angle of 88.7 degrees. All right. So that is the voltage across R4 right there. So the voltage across R4 squared, so VR4 squared divided by whatever R4 is, whatever the impedance that is. So that's going to give us 16.85 volts at an angle of 88.7 degrees divided by, and that's squared as well, sorry. Stuttering left and right here. And then we got 4.7K at 0 degrees right here. So let's see what we get. So 16.85 volts at an angle of 88.7 degrees, and that is squared. So that takes care of our numerator. Divided by 4.7K at an angle of 0 gives us 60.4 milliwatts dissipated by R4 here. 60.4 milliwatts. And that is true power. All right, that one was a bit tedious, but we did it. And that's all for this video.